All right, so I've got this file on Canvas called confidence intervals. It's got two different worksheets, median rental prices, and then UFO sightings. So we're going to start with the blank version of the file. I'm going to kind of show you how we would work through each one of the three types of confidence intervals that we talked about. So the very first one is I had some rental price data from various cities in the United States. Um, I think they might actually be in order here, but no, I guess not. Some of them are higher or lower. So we have one variable, which is just what was the and I think this was not supposed to be a 12, but 22. Over this 3-year time period, what was the average rental price in these cities? And then I created this variable where I said, and once again, I'm not going to ever make you kind of use this if or this if statement, but we should start to get used to be comfortable with them. I said if that rental price was over $2,000, put a one in this column. If it's not, put a zero. Okay. So, excuse me. The very first thing we'll do is kind of look at this and say, well, I might be interested in what the true population mean rental price is. Right? So we're going to build a confidence interval. So just as kind of a reminder, excuse me, what is this going to look like? Well, if we're doing this, let me move this around here. I think this is what I want. Um, if we're doing this for a population mean, we're going to base our confidence interval around that sample mean that we saw. We're then going to go a certain number of standard deviations to the left and to the right. So that Z value we're going to want to use, and when I say left and the right, add and subtract. It's going to be whatever Z value would give us alpha over 2, kind of on either side of our interval here. We're then going to multiply that by the standard deviation of our sample means, where the standard deviation of our sample means is the square root of the variance we sampled from, or sorry, the variance of the data we sampled from divided by our sample size. Now here's going to be kind of a weird one where I somehow know the population variance and rental price. This isn't often going to be the case, but we're going to start out here, walk before we can run, and then eventually talk about, well, what if we only had the sample variance? Okay. Get this to select screen too. There we go. So I've got these rental prices. How can I find the sample size? That's just using that count function. We'll go over, select this entire column. So Command Shift on a Mac, Control Shift on a PC, hit the down arrow, hit enter, right? And let me see, do I have, yeah, I have the 20, okay. Just want to make sure we can see things okay. Sample mean, how do we find the mean? We just use that average function. Once again, Control Shift or Command Shift on a Mac, hit the down arrow, hit enter, get back up to this cell. And let's just assume we have a population variance of 2,000, right? So that was given to us. Well, I'm going to break things down, right? What are the things that we needed here? In fact, can I drag this? Yeah, I don't know how large this will appear, but what did we need? The sample mean, our Z value, and then calculating this standard deviation of our sample means, which is what I have a header here for. Okay. So first thing I'm going to do is calculate that standard deviation of my sample means by taking the square root of the known population variance divided by my sample size, right? I'm then going to say, okay, look, what is here? So we got norm dot s dot inv, right? Because we know the area that we want in each tail, which is half of alpha, so alpha over 2, right? Now, we said if I hit enter here, it's going to give me that Z value, but it's always going to make it negative. So I could do one of two things. I could use the absolute value function, or I know that if I want alpha over 2 on the left side, I also want alpha over 2 on the right side, which if I'm looking at the right side there, so that Z value that would give me alpha over 2 to the right, the area to the left of it would be 1 minus alpha over 2. So I think I have it this way in the slides where I kind of say, oh, that's not the slides. I think they're behind here. Oh, I might have closed them out. So let's open them back up. So that's where I've got kind of this C. So 1 minus alpha over 2 is what you put into this INV function. So that's what I'm using here. Right? But you could use the absolute value as well. Now we've got that Z value. And I'm going to copy this down. Notice I included our conventional levels, but just to kind of show you, you could really do this for any level of confidence. I included 87.5 down here. Right? What would alpha be? 0.125, alpha over 2, the Z value associated with that, 1.53. Then it's just a matter of getting this, using Excel basically to be a calculator at this point. So, oops, sorry. So we take our sample mean, subtract our margin of error, which is just how many standard deviations away we want to go, times whatever the standard deviation is. Okay. So hit enter here. I get 1928. Once again, I want this exact same thing. I want this, or sorry, I want to do the exact same thing for the subsequent lower bound calculations, but I want the Z value to update, but I don't want anything else to. So Command T on a Mac, F4 or a function F4 on a PC, freeze where the sample mean and standard deviation of our sample means is. Drag this down. I've now got my my four lower bounds. I want to do the same thing for the upper bound. So I'm going to copy this formula, hit enter to get out of the cell, go over here, paste it. Nothing should change. The only thing I need to change to find my upper bound is I'm now adding my margin of error. Once again, I can now copy this down, and I very quickly have 4 different confidence intervals. Now, these confidence intervals are relatively narrow, probably because the value I chose for the population variance, I think what I actually wanted this to be. I think this was the standard deviation. So let's just say, just to make this a little more interesting, so what, 2000 would be 4 million. That probably makes a little bit more sense of what the population variance is. But notice if I have everything set up correctly, everything just updated. I've now got my confidence intervals for what the true population rental price is in the United States. Okay. So not too bad. We kind of looked at some of the, doing some of this along the way when I was going through the slides and the material, the theory, but this is how we would do it in application. What about for a proportion, right? Well, I have this variable, which is a 1-0 variable. So I can say, okay, what was the proportion of cities that had rental prices over $2,000 a month? Well, I could kind of break this down to 2 different, I could do this however I wanted to. So I'll show you one way first. Let's see. I'll give myself a little bit more room here. So I'm gonna move this here. So I could have done it this way. So number of cities over 2,000. I could have said, okay, use that count if function, select the entire variable, and I only want to count it if it's, scroll up so you can see this. Oh, there's a lot of data points here. There we go. So comma, only if it is equal to that value of 1. Okay, so 458, right? I could then say, okay, what's my sample size? That's just going to be using the count function, count the number of observations we have. Control Shift, Command Shift on a Mac, hit the down arrow, hit enter, right? And then how do I find my sample proportion? I could just take the number of cities that had over 2,000 divided by the total number of cities. I get a sample proportion of about 0.26 or 0.267. Okay. Now another way I could have done this, if I were to take the average of a 1-0 variable, what would that do? Well, it would add up all of these values and then divide by the total number of observations. Well, if I add up all these values, what is that going to give me? The number of cities over 2,000, divide by the sample size. That's exactly what we were doing before. So anytime you have this 1-0 variable and you want to find a proportion, you can actually just find the mean of it or the average function built into Excel. And notice we'll get the exact same thing. Okay. Excuse me. So the other thing that varied a little bit with these sample proportions is I'm still going to base my confidence interval around that sample statistic that I found. I'm still going to use that standard normal distribution to find the z-value or the number of standard deviations away I need to go to get alpha over 2 on either side of my confidence interval. But here, the standard deviation of our sample proportions was take the sample proportion times 1 minus that, divided by our sample size, take the square root. So we're going to put this into a separate cell so that it makes our life a little bit easier once we get to that equation for the upper and lower bound. So if I do this correctly, I should find the exact same z-values I did before, right? They're always going to be the same if I'm looking at the same alpha values. So how did we do that? Just a reminder, I said, well, I could do norm dot s dot inv, and then not alpha over 2 because we want just the positive value. So 1 minus alpha divided by 2. Okay. This should give me the z-value that I found before, right? Same distribution. Copy it down. Everything looks great. Okay. Lower bound, once again, it's really the same kind of format we were following up here, except for I forgot to do one thing, which is calculate my intermediate value, which is the standard deviation of my sample proportions. So that was the square root of sample proportion times 1 minus my sample proportion divided by my sample size. I then will say, okay, take my sample proportion, subtract, go this many standard deviations below. So this many standard deviations times what is the standard deviation. As I copy this down, I don't want anything except for this z-value to be updating. So Command T on a Mac, F4 or function F4 on a PC, freeze both of those cell references. I'm now going to copy this, hit enter to get out of the cell, paste it over here. Nothing should have changed. I have the exact same value or cell references. Let's get my upper bound. I'm going to add my margin of error. Once I have that in, I can just copy these down. And I've got 4 confidence intervals relatively quickly. Now notice a couple things to point out. As I'm going to higher levels of confidence or lower levels of alpha, I'm going to have to go a higher number of standard deviations away from my sample mean or my sample proportion to get that level of confidence. So what's happening is that width of my confidence interval for higher levels of confidence, it's getting larger, right? I have to include more values so that I can say with a higher level of confidence, I know that the true population proportion is one of these values. Another thing to point out, let's say, I don't know, I found the same sample proportion, but let's say it was only from 200 homes. So once I hit enter here, my new sample size is 200. Oh, actually, this isn't going to like it. Hold on. Yeah, so this one's going to be all screwy. So here, I'm going to set this up. So if on our sample proportion, this was take our sample size. Oops. Kind of showing you the 2 different ways that you could have found it. Nope. Okay, so I don't have my sample size, and that's why it's freaking out. Let's say instead of the actual sample size, where I use that count function, let's say instead I had a sample size of 200, but I found the same sample proportion. What's going to happen to my confidence interval? Well, my sample size is getting smaller, which means this fraction is getting larger, which means I'm adding and subtracting a larger amount. It should be getting wider, right? So if I hit enter here, oops, sure enough, all of these confidence intervals have now gotten wider, right? Now, this isn't actually what it should be. Notice my proportion thing doesn't make any sense anymore because it's not the actual sample size. So I'll kind of change that back. I just wanted to show you that to kind of have point out some of the things we talked about in during the kind of theory portion. All right, so I think that should kind of cover it. That's how we would build confidence intervals for a known population variance or a sample proportion example. So these ones are a little bit trickier than maybe the problems we were working through because like I kind of have to figure out my sample proportion Now, it's pretty easy. Like I said, we can use that average function for this 1, 0 variable, or I could count up the number of ones divided by the number of observations. Both ways give me the same value. All right, so we'll go to this other worksheet now. That was kind of a fun example where I've got UFO sightings, right? So I'm gonna do this is kind of stupid, but it's kind of a fun example. So let's look at the average duration, and this is in seconds, all right, of UFO sightings. Okay. So I can find my sample mean by just using that average function. Control Shift, Command Shift on a Mac, hit the down arrow. Oh, actually looks like, oh, hold on. Thought I vetted this data before I did this, but this one is missing for some reason. So I'm going to have to delete that for the sake of what we're doing. All right. And let's make sure there's no other missing ones. There is. How didn't I catch this before? I apologize. There we go. Now they're all in there. All right. So I'm going to find my sample mean, taking the average function of every single UFO sighting we have here. I'm going to find my sample size by using the count function. I'm then going to use the sample variance as a var.s, right? So I'm not given a known population variance here. I'm going to calculate a variance, but I'm doing it from sample data. So I'm going to select this. Right here, I've got like a huge data set. So this is going to really help me point something out here. I've got 88,000 observations here. Excuse me, but the sample variance is relatively large. So if I'm thinking about the standard deviation of my sample means, what am I now doing when I only have a sample variance and I want to build a confidence interval for the true population mean? I'm still going to build my confidence interval around that sample mean. It's just now I'm going to go a certain number of standard deviations above and below, and the number of standard deviations away I need in order to get half of alpha on each side of my confidence interval, I'm going to have to find that value from student t distribution. And then the standard deviation of my sample means is the square root of whatever sample variance I've calculated over my sample size. And I also forgot, how to identify which student t distribution to use. That's my degrees of freedom, which is just n minus 1. Okay, so let's go back to the data. So I need to find this t value. So t dot inv, right? Because I know the area that I want in the tail. It's half of alpha. Okay. Now, before I show you, okay, yeah, but if I do half of alpha, oh, sorry. Oh, why doesn't it like this? You enter to, oh, because I forgot. I'm looking at the student t. So what's the other thing I need to tell it? My degrees of freedom. My degrees of freedom will be my sample size minus 1. Put a parenthesis around this, hit enter. Now notice, I said that when we have really large sample sizes, notice this t value I'm getting. It's pretty much the same as the z value. It's at that, the point time I get to 88,000 as my sample size, this is going to be a lot closer, right? Now, I'm just going to go through, this is the actual sample size, but let's do something more interesting. Maybe where I do 88, you'll notice now it's a little bit different, right? And if I don't want this negative sign, right, I could use the absolute value function. We said we could do 1 minus alpha over 2, or I could use this t dot inv dot 2t, right? So what this does is, if you use this formula, all you have to do is tell it the probability you want. It's going to automatically divide it by 2 behind the scenes. And then you tell it your degrees of freedom, which is your sample size minus 1. Now this will return you that same value, but positive. Okay. Now, if I copy this down, the only thing I want to change is my alpha value. So I'm going to freeze, Command T, F4 on a PC, Command T on a Mac, sorry, F4 on a PC, hit enter, copy this down, okay? Now it's just a matter of, okay, what's the other thing I need to, oh, the standard deviation of my sample means, which was the square root of my sample variance divided by my sample size. Now I'm going to go and say, okay, look, I take that sample mean that I found, subtract the margin of error, which is the number of standard deviations away I want to go, times what the standard deviation actually is of the sample means. As I copy this down, I want the t-value to update. I don't want anything else to, so Command T or F4 after I select these cell references. My upper bound will be this exact same function, so I'm going to copy that, paste it, except I won't be subtracting my margin of error. I'm going to be adding it. Okay. Now I'm just going to copy this down, and I've got my 3 confidence intervals pretty quickly. Okay. I could do this for different level. Let's say I want to do like, I don't know, some wacky ones, like I wanted my alpha to be 0.27. If I have it set up this way, you just copy that down and it gives me that confidence interval as well. Okay. Now this is not really helpful if I'm thinking about the length of time that of a UFO sighting. How is it negative? Well, remember, we changed the sample size here. So if I use the actual duration, right? Or sorry, I use the actual number of observations we had, I get something that's, oh, okay, this looks a little bit more, it makes a little more sense. So on average, with 90% confidence, I can say the length of a UFO sighting is between 5,000 and 11,000 seconds, right? Which seems pretty long. But I mean, some of these have got like 4 hours where people get, some of these values are pretty large. So, our mean that we found was like 8,000 seconds. So kind of interesting. I don't know. Do that what you will. I was kind of surprised that these weren't just shorter, like, oh, I just saw a flash in the sky. There are some that are very, very long, so that you actually have the average duration is pretty high, right? 8,000 seconds, that's a while. Okay? Um, but yeah, that's how we would build confidence intervals for sample means where we only have a sample variance.